Good evening, ma'am.
Good evening, Hima.
Good evening, ma'am.
Good evening, Joshika.
Happy Teachers' Day, ma'am.
Thank you so much, Joshika. Thank you so much. So let us wait for the others as well, and then we will be revising the chapter physical and the chemical changes.
Okay, ma'am.
Okay, children, then we'll start revising the chapter. Okay, I'll just share my screen. Is my screen visible?
Yes, ma'am.
Okay. Okay. So in this chapter, physical and the chemical changes, basically it's all about the changes which happens in our day-to-day life also. So cooking is there, then kneading is there, roasting is there, each and everything. Mixing of the salt in the water, mixing of the lemon in the water. So all these are what they are the kind of the changes which happen in our day-to-day life. So, physical change, when we talk about the physical change, it is basically the change where the properties such as the size, shape, and the state of the substances will be there. The physical state, it means you can see them actually. So, when a substance undergoes a change in its physical properties, that is called as physical changes. So, like melting of the ice. So, what happened in that case? We have the ice will melt into the water. So, that is physical change where one of the form of the state, which is like solid, will get converted into the liquid form of it. And this generally they are the reversible kind of the changes in which the new substance will not be formed. Reversible change means we can change back them to the initial kind of the substances by reversing the action. Like if you have the rubber band, if I stretch the rubber band to a point, then what happened? I can bring that back to the original point without, disturbing the thing of it. Now, here's an activity given, activity one, to observe a physical change with the help of the ice cube. So, ice cubes are there. We have to see the change. Procedure, take a few ice cube in the beaker. We have to keep them open for the 4 to 5 minutes. Now, we have to observe that the solid changes into the water. So, the solid is there, and after some time, it will change into the water. So, this is what the change of the state is happening from ice to the liquid. Now, pour this water back into the ice tray and keep it into the freezer for 30 minutes. So again, when we keep that back into the freezer, what happened? This water will get again converted into the solid. Therefore, it is a kind of the physical state where we are reversing the process also. So it's a kind of the reversible process. Activity 2. Take 100 ml of water in a beaker, dissolve a spoonful of the sugar in it. So 100 ml of water we have taken, we have dissolved the spoon. Now we will get a solution of the sugar and water. Now heat the solution over the burner for some time. Now we will observe that slowly the water will evaporate and sugar is left at the solution. So when we mix with the water with the sugar and after heating that, what happened? The water which is there, it starts evaporating and the sugar will left out. We will be able to get back sugar. Therefore, it is a kind of the physical change where the sugar particles will left out after the evaporation of the water. Then the characteristics of the physical change, how we can say that the change which is happening is a physical change. So for this, what we need to do is no new or different product is formed. So you might have seen when whether it is conversion of the ice into the water or the liquid, or whether it is conversion of the water and sugar into the component. So the new product is not being formed. The composition of that substance will remain unaltered. Unaltered means unchanged. So the composition of the molecules of the substance will remain unaltered. Example, just a minute. Sorry. For example, ice melts to form water. In this example, only the appearance is changed from solid to liquid. However, the composition of the molecule of ice or water remains the same. So, what the composition of the ice, the composition of water, it remains the same. Only what is happening? Only the state is changing. You tell me.
Ma'am, I didn't understand.
Just a minute. Why my pen has stopped? Huh. So here they are saying like, Joshika, we have taken the ice, then ice has been converted into the water. Okay. That ice will have the same molecule of the water only, right? It is not like something new has been formed. Like, for example, if I am giving you so many vegetables, I am giving you, okay? And then I asked you that, Joshika, you have to cook those raw vegetable. Then what happened? Do you think so? The composition of that raw material will be same?
No, ma'am.
No, right? It will change into some other composition. It means the gravy will be formed, the molecule of those raw vegetable will get slow down or they get smaller and all. So something new substance will be formed. But here, whatever the composition of the water is there, that will remain same. Okay?
Okay, ma'am.
For every 1 gram of hydrogen, 8 gram of oxygen is required. Thus, only a physical change has been occurred here. Second, this change is temporary and usually reversible. So, this physical kind of the change, they are temporary and we can reverse them. It means the change can be reversed by altering the cause which produces the change. For example, in the activity 1, activity 2, what they have done the reversing of the process also. When they have mixed the sugar with the water, and then they have evaporated the water, the salt, the sugar has been left out. Same way you can do it with the salt also. When the salt will be there with the water, you can boil it. After boiling, the water will evaporate and the salt will left behind. Same with ice conversion into the water and water into the ice. So what they are the reversible process. Example, the water formed from the ice can be changed back to the ice by placing into the freezer. So that liquid which we got it, we can again convert it into ice when we keep it again in the freezer. Third, there is no change in the weight of the substance. So weight of the substance will remain same. So during a physical change, it is the only energy which is added or removed. No matter is added during a physical change. Similarly, no matter is removed during a physical change. Example, therefore, the mass of the substance remains same. For example, if I am taking maybe, 100 gram of sugar I'm taking, and this 100 gram of sugar, I am boiling it at 100 liter of the water. So in this condition, what happened? Whatever the amount of the sugar I have taken, that will remain same. It does not change the mass of that sugar or the salt, whatever we are taking. Physical change, switching on an electric bulb. So in that case, the bulb glows and gives out heat and light energy. The physical appearance of the bulb change. So earlier it was off condition, but later on it was on condition. So only physically that change happened. The light will come, the light will glow. Second thing, rubbing a permanent magnet on a steel rod. So when we take the permanent magnet and when we rub it on the steel rod, what observation will be there? The steel rod will get magnetized. If it is brought near the iron nail, they also get attracted. So when we rub it continuously, that steel rod will also get attracted towards
Ma'am,
that.
ma'am,
Hmm?
so physical changes are reversible,
Yes, they are reversible only.
but chemical changes are not reversible.
No, 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 no. They are not reversible.
Okay, ma'am.
So, change in physical property, the steel rod acquires the property of attracting pieces of iron. So, why this happens? It is because that magnetism property will get transferred into the steel rod. That is why that steel rod also acts as like the attracting magnet towards it. Then the third one, action of heat on iodine. So, iodine, what happened? Iodine means here the salt actually. The brownish gray crystal of iodine changed to form. In your school, you might have seen the iodine solution also. So that will be brown in color. So the brownish gray crystal of the iron will change to form violet vapor. On cooling, the vapor condense on cooler parts of the test tube to form the crystal. So when we boil that iodine solution, what happened? The brown color of it will change into the violet color. And then when we cool down, we can see that on the surface of this test tube, small crystals will be formed over it. This is what in the change in the color and the state of it. Then dissolving common salt in the water. So white crystalline salt disappear in the
Ma'am,
water. So when we, tell me.
ma'am, you said the crystals are formed, right, ma'am? But then how is it a physical change?
How it is a physical change? You're asking that.
You said the crystals were formed.
Correct, huh?
Then how will it be a physical change?
Because the iodine, they are taking in the crystal form only. Okay. Since they are taking those iodine in the crystal form, and when they are heating them, they convert them into the violet vapor. Suppose this is a test tube. In the test tube, I have taken the iodine crystal form of it and I am heating it. So when I'm heating, the vapors will be in the violet color. And when we make it cool it down, again those crystals will appear here. Got it? The same crystals, the same vapors will come back. I think condensation you might have learned, right?
Yes.
There is a surface, like you are boiling a pan, okay? And when you keep the another plate over that pan, the evaporation which is happening, that steam will come back to this pan, right? Same way, when they are heating the crystal of the iodine, those vapors which are going out, they are condensing those vapors, and when they come down in the form of the crystal only. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So some common example of the physical change: formation of dew, evaporation of water, crystallization of sugar from its solution, ringing of electric bell, breaking of the glass pane, freezing of the ice cream, a rock rolling down the hill, bending of glass tube by heat, melting of wax, sublimation of the camphor. These are some of the physical change. Now coming to the chemical change, in the chemical change, the properties itself will get changes. So a change which all, yeah,
Melting of wax, it will produce heat and light, ma'am.
yes,
So it will be a chemical change, right, ma'am?
no, see, that is burning of the candle when you talk about. There is a
Oh,
difference. There is a difference between two. When you burn the candle, when the candle is burning, in that case, it is the chemical change which is happening. But in the case of the melting of the wax, the same property will be there before and after. Only the shape of it will change. Correct? If you are taking the straight shape, that will come down a normal kind of the shape.
yes, ma'am.
Now, chemical change, a change which alters the specific properties of a material by bringing about a change in molecular composition. So here, the molecular composition of it will be changed. Just a minute, let me see who all have joined. Sneha, Lishika, and Charlie, any doubt?
No, ma'am.
Okay. So on the other hand, we can say that when two or more substances react in such a way that there is formation of one or more new substances, that change are called as a chemical reaction. So chemical reaction, the word itself says that, right, certain kind of the chemicals will react together and that will lead to the formation of the new substances. So in this chemical reaction, two things are there. The first side, on the left hand side, there will be the reactant, and on the right hand side, which is formed, that is called as a product. So this reactant can be A, it can be also the B, it can be the C. They can be three reactant also which join together. And in the product side, it can be D, or it can be along with a D, it can be one more substance which can be formed. So this is what the chemical reaction, or which we say as a chemical equation also. So chemical equation, all chemical changes are accompanied by chemical reaction. These reactions can be described in the sentence form, but the description would be quite long. Therefore, what do? We write in the chemical reaction form. So if I write those, reactions like this, I'm writing zinc plus hydrochloric acid, then give zinc chloride and hydrogen. So too much of time it will be taking. This is what the chemical reaction will be, when we write in the complete sentence form. That is why what do? We write them in the equation form, so it becomes easy for us. So same thing, I can write it in the equation form. So I'll be writing Zn plus hydrochloric, which gives us the ZnCl plus hydrogen. So it is easy to write rather than writing the complete name of all those elements and all. So a chemical equation links together the substance which reacts with the new substances that are formed. Now reactant, they are the substances which parts in bringing about the chemical change. So left hand side, which brings the changes, they are called as a reactant, and product, they are formed as a result of the changes, they are called as a product. For example, zinc and hydrochloric acid, these are given on the left hand side. So what they are the reactant, and when they both combines together, they form the product, which are the zinc chloride and the hydrogen. So this reaction involves what? Breaking and making of the chemical bond. So during this time, what happened? There will be the breaking of the bonds. There will be actually also the making of the bonds. Then the next one, irreversible change. They are the irreversible change. So once we have converted them into the some product, we cannot reverse the reaction. So a change in which we cannot back the initial substance by reversing the action is called as the irreversible change. So now this zinc and hydrochloric acid has reacted together and
Ma'am,
they
I
form
have a
zinc
doubt.
chloride. Tell me. Tell me.
Chemical changes are irreversible changes, right, ma'am?
Right.
So now, rusting of iron is a chemical change, right, ma'am?
Hmm.
But then we can reverse it by a process called galvanization.
Galvanization. Yes, we can do that. We can do that. Certainly, we can do that. See, rusting of iron, what happened? It is an entirely different process, though we say it is a chemical process, but it does not involve each and everything as like what the chemical change includes it. So, chemical change says that all the properties should change, right? Whatever the composition is there should change. It also says it is irreversible. So it is not important that all these criteria should be followed by each and every component, or each and every example should follow all of these things. So some will not follow these criteria. Okay. So in the case of the rusting of iron, what happened? The rusting of the iron will change the formation of it, will form the layer, the brown color layer on it. But at the same time, it can be reversed by the galvanization process. So here the activity third is given to observe the formation of new substances on heating the magnesium ribbon and then adding water to it. So here what they have taken a magnesium ribbon and then they have added the water to it. So we have to see what type of the new substance is being formed. So take a small piece of the magnesium ribbon, clean it strip by rubbing with a sandpaper. So magnesium paper we have to clean it by rubbing it on the sandpaper and then hold it with the pair of tongs. This is called a tong. So with the tong, we have to hold it, otherwise we will burn our hand itself. So hold it with a pair of tong over the flame of a burner. Now we will observe that it burns with a brilliant white light. So automatically when we start burning it, what happens? The white light comes out of it. It leaves behind a powdery ash after the burning. So that white light, at the same time, it starts releasing that ash. And that ash comes from where? That ash comes from the magnesium ribbon only. So those white light will convert this magnesium ribbon into the ash, powdery form of ash. The ash obtained is not the same as the magnesium ribbon. So magnesium ribbon composition was something else, but the ash now which we have got, it's something else. Like another example is like if the human body is there, if the human body we are burning, then what happened? We will be getting the ash only at last when after the burning. So that ash is not similar like the human body. Same way, magnesium ribbon, when we burn it, so the
Calcio, questo punto.
come
Teachers
again?
do have calculus, please. Ma'am,
Yeah, tell me.
ma'am, why is it needed to polish with the sandpaper, ma'am?
To clean it. See, if it is not being cleaned, then what happened? Ultimately, the problem will be there. The effect of that white light will not be there. Okay. So to clean the surface of the magnesium ribbon, we have to use a sandpaper. If we take the normal paper, which we are using to write, it does not clean it. Sandpaper is little rough kind of the
Yes,
paper.
ma'am.
Okay. So since it is rough kind of the
Okay.
paper, what happened? It makes that magnesium ribbon clean easily.
Okay, ma'am.
Okay, so this is
Yes.
how it will be. So magnesium has lost its property and the new substance magnesium oxide will be formed. So in this case, the magnesium is reacting with the O2 and what do they form? They form the new substance called as MgO, magnesium oxide. So magnesium reacts with the oxygen, they form the ashes and that ashes is basically the magnesium oxide. Collect the ash in a beaker and mix with a small amount of the water and then stir it properly. With the help of a dropper, put the drop of this solution on red and blue litmus paper to test its chemical nature. Now, what you need to do, you have to add some water to it, and then one drop of or two drops of that solution you have to add it on the red and blue litmus paper. Now we will observe that red litmus paper will turn blue and blue will remain same. This shows that the solution which is obtained, which is MgO, is what? It is basic in nature because it has turned the red litmus paper into the blue color. Okay, so it is basic in nature. So what we can conclude, magnesium oxide on dissolving in water, they form the magnesium. So when you take this magnesium oxide and when you add it into the water, what happened? It form again the new substance, which is the magnesium hydroxide, which is again the new substance, that thus is the kind of the chemical change. Again, I'm explaining you in this what we have to do. Magnesium ribbon we have to take, we have to clean the tip of it with the help of the sandpaper, and then we have to burn it. So as we burn it, the white color light will come out, and at the same time that magnesium ribbon will be releasing it out in the form of the ash. That ash we have to we have to add it in the water, and then we have to test for the litmus, and ultimately the red litmus will be turning into the blue one, which shows the basic nature. And when this magnesium oxide which is formed there, when it reacts with the water, it gives us again the new product which is called as a magnesium hydroxide. So these are the reaction: magnesium, oxygen, which gives us the ash, which is magnesium oxide. And now when magnesium oxide touches the ash, we're adding the water, it gives us the new product, magnesium hydroxide. Thus, we can say it is a kind of the chemical change. This is there in your grade 10 actually. Am I clear, children? Joshika, Snehal, Charvi, Shreyansh, Himank, Chika.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, another example, we have another activity we have. So, to observe the formation of new substance on putting an iron nail in the copper sulfate. So, copper sulfate is basically blue in color, and iron nail, you know what is the color of that. So, what we need to do, take 100 ml of water in a two, take 100 ml of water in 250 ml beaker. So, there will be a beaker that in that beaker, we have to add 100 ml of the water. Now, dissolve a spoonful of copper sulfate, that is the blue vitriol or Neela Tota in color. Okay, the copper sulfate in Hindi it is called as Neela Tota, and in the other name of copper sulfate it is also called as blue vitriol. So that is why the color of it is blue. Add a few drops of the dilute sulfuric acid to it. Now after this, what do we need to do? We have to add the dilute sulfuric acid. Sulfuric acid is H2SO4. So dilute sulfuric acid we have to add to it. Now we will get a blue colored solution. So as soon as we add it, we will be getting a pakka blue color to it. Divide this solution into two equal parts. So what after adding the H2SO4 sulfuric acid, we will be getting that proper blue color. Now we have to divide that solution into two parts. To the second part, drop an iron nail. Now this is the first part here, this is the second part. In the second part, which was also the blue in color, what we did, we have dropped the iron nail to it, and we have left it for the 30 minutes. So after leaving that iron nail for 30 minutes, compare the color of the solution in both. So you will be able to see that blue color of the solution will change into the green color. So in the first one, it remains as it is because there was nothing was added into that solution. Whereas in the second one, where we added the nail to it, it converted into the green color. And also a brown color layer will get deposited on the iron nail. So you can see on this nail, there is a brown color covering which is being formed. Now, what we can say that, what we can conclude with this, copper sulfate solution is blue in color. It changes to green color due to the formation of new substance which is called as the iron sulfate. So what happened? There is a copper solution sulfate which we have taken, and when it starts reacting, they convert into this reaction. So this is what we have taken, right? Copper sulfate we have taken, and then iron nail we have added. This is iron nail, okay? Fe means iron. Now, when the copper sulfate has reacted with the iron nail, what they did, they changed the reaction, they changed the substances, which is called as now the ferrous sulfate, and this copper layer will be formed on the iron. So that is what, this is the reaction. So copper sulfate reacts with the iron sulfate will be formed, and copper will be there, which is brown in color. That is why we say it is a kind of the chemical change. Am I clear, children?
Ma'am, is H2SO4 the strongest acid?
Yes, that is why it is called as king of all the acid.
Okay, ma'am.
Okay, now the next one is displacement reaction. In this condition, the iron is more reactive than the copper. See, there are some, some kind of the things you should understand now. When you talk about the table, there will be the periodic table. In that kind of periodic table, there will be reactivity, that which kind of the elements reacts more. So in that condition, the iron, when we compare, 1 minute. When we compare the iron with the copper, this iron is more reactive. That is why what happened, the iron which was present alone, what do? They go and shift their place. And this copper will get out because it is less reactive. Okay. So always a strong element will take the place and the less reactive will remove out. This is what a displacement reaction. So iron replaces copper from copper sulfate solution to form the iron sulfate. So that is what happened. The iron will take place of the copper and copper will be alone and we get the iron sulfate. Such reaction in which a more reactive metal replaces a less reactive metal from its solution is called as a displacement reaction. Second example, when we leave cut slices of apple, brinjal, potato, they acquire a brown color. You might have seen. So whenever we keep the apple for some time, the cut apple or the potatoes or the other fruits and all, so what happened? The brown color layer will be formed. It is because of the formation of new substance on reaction with the atmosphere. So in the atmosphere, what will happen? There will be the other component also which is present, other gases which is present. They start reacting with them and they convert them into the brown color. Now, other examples of the chemical change, burning of the wood or charcoal, formation of the gobar gas, ripening of food, baking of cake, electrolysis of water, burning of candle, clotting of blood, photosynthesis, digestion of food, curdling of milk, burning of petrol, drying of paint, formation of wire, formation of water, butter turning into the rancid, then rusting of iron. These are some of the examples of the chemical change. Now, the characteristics of the chemical change, evolution of gas, which is very important. Most of the reactions of the chemical reaction will help in the release of the hydrogen gas. So whenever any reaction happens, what happens? The hydrogen gas will be released. For example, when zinc will add to the dilute sulfuric acid, hydrogen gas is evolved. If a burning matchstick is brought near the mouth of a test tube, it burns with a pop sound. So how we can identify that the hydrogen gas is released? So what we need to do, whatever the substance we have, like here we have two substances, right? Zinc and sulfuric acid. So we have to take the zinc in the test tube and slowly and gradually we have to add the sulfuric acid. Then when we are doing this, we will be able to see that on this test tube, a pop pop kind of, a kind of the pop pop sound will be coming out of it. So that pop sound basically reflects the evolution or the releasing of the hydrogen into the atmosphere. Understood how to check whether hydrogen is releasing or not?
Yes, ma'am.
Yes, children, understood?
Yes, ma'am. Yes,
So
ma'am.
if that pop sound is coming after mixing those kind of the chemicals, then definitely it means that is the hydrogen gas. Next one, change of color when solid lead nitrate, this is lead nitrate. It is heated, reddish brown nitrogen gas outside is evolved and also a yellow color lead monoxide is formed. So in this condition, what happens when the lead nitrate will be, when we heat them? So there will be the nitrogen dioxide will be formed, lead oxide will be formed and the oxygen will be formed. So three new substances will be formed when the lead nitrate is being heated. Then formation of precipitate basically means a solid substances. So when we heat something or when we, do some experiment, there will be something left out in the test tube, a small solid thing that is called as a precipitate. For example, copper sulfate, when it is actually reacted with the hydrogen sulfide, what happens? When hydrogen sulfide gas is passed through the blue color copper sulfate, a black precipitate of copper sulfide will be formed. So when these two reactions are happening, copper sulfate reacting with the hydrogen sulfide gas, we will be noticing that at the bottom of this tube where the reaction happens, there will be the black color of precipitate, which is the copper sulfide precipitate will be formed. So always in the chemical change, the formation of the precipitate will be there, evolution of the gas will be there, change of the color will be there. Then also the evolution of the heat, light, or any other radiation will be there. I think Joshika also mentioned in the beginning of the class. So heat, light will also be released during the chemical changes. The other two changes which are there are the endothermic and the exothermic reaction. In the endothermic reaction is the reaction in which heat energy will be absorbed. And exothermic is the heat energy will be evolved out of it. So endo, inside, the heat energy will go inside, whereas exo means outside. So that heat energy will go outside. The next property, sound may be produced. So you might have seen when you are taking the vinegar, you can do this experiment at home also. Take some amount of vinegar and then add the baking soda to it. So you will be seeing that there will be some hissing sound will be produced. So sometimes in the chemical change, this sound will be there. You try this experiment if you have the baking soda and vinegar at your home. Okay?
Yes, ma'am.
Ma'am, I think the hissing sound comes when like the two chemicals burn.
Yes, two chemicals burns when they not burn. We cannot say burn when they react actually.
And they are corrosive.
Yes, they are not corrosive. See, when we talk about the vinegar and all, they are not corrosive in nature. It's not about the corrosivity of it. It's because of the reaction which is happening with them, and it produces the sound of it. It is not dangerous.
Okay, ma'am.
Okay, and the change of the smell will also be there, or a new smell will be given off. For example, when cooked food containing oil and fat is kept in the open for long, the food gets spoiled, right? And we get the foul smell. So smell will also be there, change in the smell of it. Then corrosion, it is basically a gradual deterioration of the metal. When they come in contact with the environment, it happens because of the chemical reaction between them. So because of that, the corrosion decreases the usage period of it. So whatever, wherever the corrosion happen, that will decrease the usage. So earlier, if without the corrosion, we can use it for 1 year, but because of the corrosion, we can maybe use for the 1 month. So it decreases the life of that particular thing. Then rusting of iron, when the iron is left exposed to the moist air, a new substance with a brown flaky layer will be formed on the surface. That is called as the iron oxide. That is called as rust also. So the rust falls off the surface, exposing the iron beneath it. This is a reaction when iron reacts with the oxygen and the water. The rust is formed, which is also called as hydrated iron oxide. Rusting of iron takes place in the presence of both oxygen and water. Very important point. This is they need both of the thing. They need the oxygen, they need the water. If any one of this is not present, then rusting will not occur. Rusting of iron will become faster if the content of the moisture increases. So if the moisture is more, then it becomes more. Rusting will become more. Rusting is faster in the salty water because of the presence of salt. We react in a faster way. How we can prevent it? We can prevent it by applying the grease, by painting, galvanization, then electroplating also we can do, by alloying we can do, all these things we can do it for this. So grease will form a kind of a layer which does not allow the oxygen and the water to react with it. Painting also will form a kind of the layer. Galvanization is basically the process in which the layer will be formed, the other layers will be formed, because of which it cannot react directly with the water and with the oxygen. Electroplating, they will not be attacked by the moisture. Because of that, the coating will be done and it can provide them from the rusting. For example, in the wheels also, the cycle wheels and all, they will have the electroplating. Because of that, they will not get affected by the rusting. Then alloying means when they are mixed with the certain material, the non-metal, so that the rust cannot be formed. I think just a minute. So give me still in 1 minute. Let me see if I have the vinegar and I have the baking soda. I'll get it and I'll show you how the hissing sound will be produced. Okay. Just a minute. So children, can you see me now, I guess? You can also turn on the video now.
Yes,
So I
ma'am.
have got the glass here. I have got the vinegar. White is not so visible. Vinegar I have got the soda also now. So what we need to do, a little amount of the vinegar. Wait, let me remove the background first of all. None. I think now it is visible. Fine, so I have taken the vinegar here. What I'll be doing is I'll be adding the soda. So I think it is visible now, right? Can you see?
Yes, ma'am.
Yes, ma'am.
See, still it is coming, that sound is coming. So this is what, see how it happens when the vinegar reacts with the baking soda. The reaction will be happening and it is not harmful for us because vinegar we are using in our day-to-day life. At the same time, still the sound is coming from this. The vinegar is not harmful, neither the baking soda is harmful because we are using our day-to-day life. So such small experiment, there are many experiments related to the acid basis of salt chapter, which is very interesting actually to understand. So you can also try at home. Take a little amount of the vinegar and add the baking soda to it. You will be able to see clearly the hissing sound which is coming out of it. Okay. So that's about the physical and chemical changes chapter. If in case now you have any doubt, you can ask me.
No, ma'am.
And children, today you have one more class, which is like at 7, where the sir will be, not sir, sir will be revising the perimeter and area chapter. So if you wanted to cover that chapter, perimeter and area, you can join that class at 7. And I think most probably tomorrow and on Sunday also we'll have the class for some other chapter in the maths. So if you wish, you can join those classes also.
Okay,
Okay?
ma'am.
Okay, children then. Thank you.
Thank you, ma'am. Bye, ma'am. Have a
Thank
nice
you.
day.
Bye,
Bye-bye.
ma'am.
Thank you. Bye.
Bye, ma'am.
Bye-bye.